Good day, grade 11s. Today we are going to look at finding the solution, the general solution when there's more than one trig function. So that means in your equation, it's no longer going to be just sine only or tan only or cos only. You are going to have a situation like this one that I have here, where you now have, in one equation, you have sine and cos. Okay, so how are we going to deal with this? We are still finding the general solution, and in this case, even the restriction has been given. So that means after finding the general solution, we need to find the exact values. Okay, so here, remember we did trig identities. We are going to use those trig identities to ensure that in your equation, you only have one trig function. So we are going to make use of this one, that we know that tan theta is equals to sine theta over cos theta, and also that sine squared theta plus cos squared theta is equals to 1. So that means we are going to use this to manipulate the equations that we have, so that we ensure that we only have one trig function. So if you look here, we've got sine and cos. Like I've written here is that since we've got sine and cos here, those are the two things that make tan. So that means we can divide by cos, so that, because we know that sine over cos is equals to tan, so we can't divide by sine. So we divide by cos, so that we can have sine over cos, and then cos over cos is 1 and 0 over cos is 0. So then the equation is then going to look like this, which is now something that we are familiar with. So now it has become tan theta. So I'll say it again. Because we've got sine here and cos there, those are the two trig functions that make tan. So whenever you see sine and cos, you know that you must make tan. Okay, so that's what I have done here. And then then you do your analysis. This I'm not going to do anymore because you guys are familiar with. We find our theta 53.13 plus k times 180, where k is an integer. And then theta number 3 will be 233.13 plus k times 180. Remember, because this is tan, that is why it is 180 here. And then now, because we were told that the restriction is 0 to 360, that means we are using k, which is equals to 0. There's no repetition, so we are just working within those 4 quadrants. So our answers are going to be just 53.13 and 233.13. Remember, you have to, if you are given the restriction, you have to get to this point where you are listing your values. Okay, let's look at the second example. Second example is 2 cos theta equals to cos theta. Now if you check here, we've only got one trig function, which is cos. So that means we are not going to divide by anything, because now we've got cos only. But now the only difference is that now this side cos is squared and this side it is not squared. So that if we see square here, it means it is quadratic. So you know how to solve quadratic equations. Everything must go to one side. So this comes over to the other side. It is quadratic. After you've done that, then you have to factorize. So what is common here is cos. So we factor out cos theta. Then we are left with 2 cos theta minus 1 equals to 0. Okay, and then you factorize. After you've done your factorization, that means this is going to be equal to 0, or the bracket is going to be equal to 0, which now gives you 2 equations that you must solve. Okay, so I did my solution for this. I got 90 and 270. Did my solution for this. So when you do your solution, it's like the previous work that we have done. We're not changing anything. So here I found 60 and 300. Now again, because k is equals to 0, that means my solution from this one is going to be 60. From this one is going to be 90, because 0 times 360 is 0. So it's 90, and then 270, then 300. Okay, then I have to list my solution, because I have been given the restriction. Okay, then the last example, if you check here, it reads cos theta plus sine theta multiplied by 1 minus 2 sine theta equals to 0. If you check here, this already sits inside brackets, so that means it has already been factorized. Do not FOIL because it has already been factorized for you. If you do that, then you're going to complicate things for yourself. Okay, so it's already sitting in a bracket, so that means when all you do is just say this bracket equals to 0 or this bracket equals to 0. So we've got that equals to 0 and this equal to 0, and then again you've got two equations that you must solve. Okay, so when you check this side, this one has sine theta, cos theta and sine theta. So that means here, because we've got sine and cos, we have to divide by cos so that we form tan. Okay, that's what I have written here. So cos divided by cos is 1, sine over cos is tan, 0 over cos is 0. So you've got a situation like that where now you've got -1. That means we must find the reference angle. So our reference angle is 45. Then our two theta values is 135 and 315 as general solutions. Okay, then you do the same this side. The general solutions is 30 and 150. So now again, for k equals to 0, my two solutions, my solutions will be 30, 135, 150, and 315. Now, because maybe I can just mention here, because k here is k times 180. You could have also used k equals to 1. And if you use k equals to 1, this 135 plus 180 gives you 315, which is a repetition of this one already. So there's no need for you to carry on. So you can just use k equals to 0. Okay, I hope that is clear. Please do exercise 13, number 1A, and number 3, 4, and 5. By number 3, you can use the identity number 2, the one for sine for number 3. You'll see where you've got a square. So here use identity. My pen is on strike. You can use identity number 2. Okay, thank you.